My name is Chaitanya, Physics faculty at Shakthi International School. Today, in this video, we are going to learn an important topic of class 11th from the chapter Waves. Okay, we are going to discuss about interference. See, interference is a phenomenon which occurs when two waves, two waves of same frequency traveling in same direction superimposes. Okay, when two waves of same frequency traveling in the same direction superimpose on each other. Okay, when they superimpose on each other, it resulting in intensity of those waves, intensity being maximum at few points at some points, and intensity being minimum at some points, minimum at some points. Now this phenomena of resulting intensity, resulting intensity varying with respect to time, varying with respect to time is what we call it as interference. Interference. I hope you can see it now clearly. Two waves of same frequency traveling in the same direction, if they are superimposing on each other, okay, the resultant of that wave which is coming, the intensity sometimes at some points it will be maximum and at some points it will be minimum. Now this phenomena of occurrence in which intensity is varying with respect to time is what we are calling it as interference. Now why does this interference happen, when does this happen, all these things, and how it should be happening, we will learn. Now in general, equation of a wave, if you are giving, wave is a function of both time and position. So general equation of a wave, you know, we can write it as A sine omega t minus kx plus or minus kx plus or minus phi. In general, we can write the equation like this. So let's say, and you know how the equation is written depending on whether the wave is traveling in positive x direction or in negative x direction. That means if omega t and kx are having same sign, then the wave is traveling in negative direction. If omega t and kx are having opposite sign, then the wave should be traveling in positive direction. Okay, now let's say we are taking two different equations. It is necessary that the frequency of it is same. It is not that the amplitude should also be same. Amplitudes can be different, but they should be almost approximately, uh, there should be no big change in the amplitudes. Okay, so we can take it as a1 sine omega t minus k x1, where x1 is the position. It is not necessary the distance of the wave that is being traveled by the both the waves are same. They can be meeting at different positions. Y2 can be written as a2 sine omega t minus k x2. Here coherent sources we are taking. Coherent in the sense there is no change in frequency, there is no change in time period, no change in the there is no phase difference because of time period. Okay, so I hope you understood this one. Now these two equations, when they are superimposing, you are going to get another equation. Let's say this is one wave, which is going in this direction. There is another wave which is going in this direction, superimposing at these two. This is traveling an x1 distance, this is traveling an x2 distance to reach that point. Here, when they are superimposing, you are getting a y-net equation, which can be written as y1 plus y2, and we have to add them vectorially. So when we are adding vectorially these two equations, so y net, you can write it as y1 bar plus y2 bar. Now, amplitude net of it can be written as, since amplitude is a vector, and you know there is a phase difference between these two waves, the phase difference can be written as delta phi. The angle between those two amplitudes can be written as delta phi. This is A1 and this is A2. I can represent it as either delta phi or phi. Okay. From where do we get this phase? Now, this entire angle is what we are calling it as phase phi 1. This will be the phase phi 2. Okay, this is your phi 2 as your phase. Now, phase difference, if you are trying to understand, which is delta phi can be written as phi 2 minus phi 1, which can be written as omega t minus kx2 minus of omega t plus kx. So these two gets cancelled. You can write the equation of it as k times of delta x. So delta phi can be written as k into delta x. This is a general equation. Phase difference due to path difference. So that phi can be calculated further. Delta phi can be written as 2 pi by lambda into delta x. Since you know the value of k is going to be 2 pi by lambda, we can use this equation for finding it. Now, since two amplitudes are having a phase difference of phi between them, if you are trying to find the resultant vector, A resultant, okay, a resultant or a net can be written as under root of a1 square plus a2 square plus 2 a1 a2 cos, the angle between them is phi. This is the general equation of amplitude that we will be getting. Now, in general, we know we know from previous understanding of waves, I is always proportional to a square. Angular intensity of wave is always proportional to amplitude square. So that means you can write I1 is equal to k times of a1 square, and I2 can be written as k times of a2 square. When we are removing this proportionality symbol, we are introducing a constant here. So if it is I1, it should be proportional to a1 square. If it is I2, it should be proportional to a2 square. If it is I resultant, it should be proportional to a r square. So now, further manipulating this equation, instead of analyzing in terms of amplitude, I want to analyze in terms of intensity. So I resultant is equal to a1 square. In place of a1 square, I can write I1 by k plus I2 by k. In place of a resultant, I can write IR by k plus 2 a1. From here, a1 can be written as root of I1 divided by k into root of I2 divided by k into cos phi. Further, if we are solving this equation, since the value of k can be cancelled, you can write I resultant is equal to I1 plus I2 plus 2 root I1 root I2 cos phi. Now, this is the general equation of amplitude. These two are the general equations of amplitude and intensity that we have here. If you want constructive interference, the point where we are saying that it will be maximum, we deem it as constructive interference, and we will have a destructive interference. So now, if you want to understand about constructive interference, okay, the amplitude should be maximum and intensity should be maximum. Destructive interference, amplitude will be minimum and intensity which should also be minimum. Okay, we are talking about interference being changing with respect to time, right? It will be maximum at one point, it will be minimum at one point. When it will be maximum, if those two waves are constructively interfering on each other, we there you will get an interference, the amplitude and intensity to be maximum values. When can amplitude and intensity be maximum? When your cos phi, since all these values are constants, the only variable that we are having is cos phi. That cos phi should be maximum. The maximum value of cos phi will be ranging from 1 to minus 1 to plus 1. Okay, so the maximum value it can have is plus 1. So where can it should be having cos phi to be plus 1? When angle phi is equal to either 0 or 2 pi or 4 pi or 6 pi and so on. All the even numbers you will be having cos phi to be maximum. All the even angles. Cos phi, if you want it to be minimum, then it should be negative. So where it will be possible? At angle pi, 3 pi, 5 pi, 7 pi, and all it will be possible. Now by substituting this value of cos phi, that means here it should be maximum. You can write a resultant as a maximum as a1 square plus a2 square plus 2a1 a2 you will be getting, which can be further written as a1 plus a2 whole square, which is equal to a resultant square. So that means a resultant can be further written as a1 plus a2 alone. In the same way, a minimum can be written as a1 minus a2. If it is a1 is equal to a2, then amplitude will be 0. In the same way, I maximum. How do you write I maximum equation and how a minimum equation? The same formula you will be applying in these two, I maximum and I minimum. So I max can be written as root of I1 plus root I2 whole square. In the same way, I minimum can be written as root of I1 minus root I2 whole square. Okay, so where we are getting this directly by substituting it in its original formula, root I1 I1 plus I2 plus 2 root I1 root I2 cos phi. In that cos phi we have substituted 1, you will be ending up with this equation. Now, I hope you understood at what angles you will be having constructive interference and destructive interference. Now, we are not concerned only about the angle, we are concerned about the path difference also. We know a general formula that delta phi, which is a phase difference, is equal to 2 pi by lambda into path difference. So, we can analyze two waves if they are having a path difference. Of what path difference will bring you out a constructive interference, of what path difference will bring you out a destructive interference also can be analyzed here. So now we know that these angles should be, in this case if you are taking 0 as your initial angle, 0 is equal to 2 pi by lambda into delta x, resulting in delta x will be 0. So if the path difference between those two waves is 0, there is no path difference, then there will be a constructive interference between those two waves. In the same way, if you are substituting the next 2 pi is equal to 2 pi by lambda into delta x, will bring you a result of delta x being lambda. Delta x is equal to lambda. In this way it is 2 lambda, 3 lambda, 4 lambda. In all these positions you will be getting a constructive interference. In the same way, for destructive interference, if you are substituting it as pi is equal to 2 pi by lambda into delta x, these two gets cancelled, delta x will be equal to lambda by 2. Further, if you are substituting different values, the change in positions, if the path difference is lambda by 2 or 3 lambda by 2 or 5 lambda by 2 or in general 2n minus 1 into lambda by 2, where n is equal to 1, 2, 3 and so on, you will be getting a constructive interference. You can write a general formula for here as well. When delta x is equal to 0, lambda, 2 lambda and so on n lambda, where n values will be ranging from 0, 1, 2, 3 and all these positions you will have a constructive interference, and here you will have a destructive interference. I hope you understood about constructive interference and destructive interference clearly. We'll meet in the next video. Thank you.